When you start learning about data science, it's easy to picture a dataset as a perfectly organized archive, a place where every piece of information is neatly categorized, fully intact, and ready to be read. Then you actually get your hands on production data. You realize pretty quickly that the archive has been severely neglected. Pages are ripped in half, chapters are glued together, and entire volumes are just missing. Academic tutorials usually hand you a clean spreadsheet where every row and column lined up flawlessly. The reality is that the data we extract from the real world is inherently messy, noisy, and highly incomplete. Handing that raw, messy information directly to an algorithm is a guaranteed way to build a failing model. Before a machine can learn anything useful, a data scientist has to step in, diagnose the damage, and triage the records. This process is called pre-processing. To understand why pre-processing is a requirement, you have to look at how these models actually learn. A machine learning algorithm is simply a mirror reflecting its training data. If you feed an algorithm a broken record, it doesn't recognize a flaw as a mistake. It accepts that flaw as absolute mathematical truth. It's the oldest rule of computing: garbage in, garbage out. Algorithms don't have common sense. They cannot independently reason that a blank cell was a server glitch or that a duplicated row was a typo. Humans have to make those repairs before the machine begins memorizing the patterns. A damaged record teaches a machine nothing true. Pre-processing is the act of repairing reality before the reasoning begins. Let's look at the first major flaw you'll encounter. Think of these as the stuck pages, redundant, duplicated rows of data that were accidentally recorded twice, or 10 times, or even 1,000 times. This chart shows how algorithms weigh information. Repeated records are assigned massive mathematical importance. Data scientists expose this using df.duplicated.sum, revealing the false repetitions. Finally, df.dropduplicates slices away the extra copies. By removing those duplicates, we prevent the machine from confusing blind repetition with statistical significance. The second major flaw is much trickier to handle. These are the torn pages, the missing data points, usually labeled as NA, or not available. When staring at thousands of incomplete rows, the human instinct is to delete the flawed records out of pure frustration, using a command called df.dropna. But there is a mathematical risk to dropping rows. If you work with a low-quality dataset, dropping every row with a single missing value might leave you with absolutely no training data left. The alternative is incredibly tempting: lazily guessing the missing information using df.fillna, which lets you plug the dataset's average value into every blank space. Filling gaps purely for convenience is dangerous. You are taking fabricated information and injecting artificial human bias directly into the model you are trying to train. Instead of guessing, a data scientist has to ask why the information is missing. Often, the gap itself holds more information than any number we could invent. Take a look at this image of an active airport terminal. If we are analyzing a dataset of these flights, and seeing an NA in the departure column means it's highly unlikely someone forgot to record it. That missing departure time proves a physical reality. The flight was canceled entirely. Pre-processing is a rigorous act of intellectual reasoning. If we blindly fill in a fake departure time to make the code run, we've replaced reality with a fiction where that plane actually took off. If we ignore the stuck and torn pages, the algorithm will confidently echo our own broken reality back to us. Look at this diagram showing the feedback loop between user interaction, data, and algorithms. When missing data slips through, it leads straight to systemic failures. Once a model is deployed on flawed data, its skewed decisions produce biased data that constantly reinforces the original error. Rigorous data pre-processing is the final safeguard of objective reality. It is how we stop the amplification of error. So the duplicates are all pruned, the missing gaps are completely reasoned with. The data shelf is finally pristine. But just as you finish cleaning, you spot a new anomaly, a single piece of data that is complete, but wildly outside the expected pattern. How does a data scientist handle a mathematically valid but structurally disruptive outlier?